In this video, we're going to explore the quadratic formula. I mentioned the quadratic formula in my previous video where I talked about the different scenarios you might come across when factoring a trinomial that is in standard form. You might get to a trinomial that looks as though it's not factorable, and that's not necessarily the case. What we're able to do is actually use the quadratic formula to find those x-intercepts. So let's dive in and take a look at the magic the quadratic formula can do. Okay, so the quadratic formula is a formula for determining the roots, right, which is the zeros or the solutions of a quadratic equation in the form of ax squared plus bx plus c. Okay, so what I'm going to do is I'm going to show you, actually maybe you also want to make a note here, just as a reminder. Your x-intercepts are also known as roots, zeros, or solutions, okay? So if you ever see those terms, you know they're talking about the x-intercepts. Just a little sub-point here. Okay, so the quadratic formula looks like this. X equals negative b plus or minus. In the textbook, it might actually look like, I'll draw it a little bit bigger. It probably looks like this, where it's like all attached. Okay, it's the same thing. The square root, whoa, Procreate does not make that shape. I'll have to just try and draw it as straight as I can. Of b squared minus 4ac divided by 2a. All right, I would recommend keeping this formula handy, like maybe write it at the top of your page or put it on a sticky note so you can take it with you from page to page in your notes, because we're going to be making reference to it throughout this whole video. So let's put the quadratic formula into action here. I'm going to write down here a quadratic equation. We have 2x squared plus 9x plus 6 equals 0. Lovely. And you know what? Over here, I think I'm just going to write our quadratic equation for our reference throughout. So I've got negative b plus or minus the square root of b squared minus 4ac divided by 2a. Just draw a little. Supposed to be a rectangle. There we go. I have a little box around that. Perfect. Okay. So what we're going to do is we are going to look at the quadratic equation we've just been given. It is in the form of ax squared plus bx plus c, right? We know that when we're looking for the x-intercepts, we have to set the equation equal to 0. They've already done that for us. It's already all set up and arranged nicely. So let's extract information from this quadratic equation so that we can substitute it into the quadratic formula. So what I see here is I have for my, well, let's look in the quadratic formula first. I need to find an a value. I need b values, right? I see a b here. And I need c values, right? So let's go ahead and pull those out of the equation we've been given. I see that I have an a value that's equal to 2. I have a b value that's equal to 9. And I have a c value that's equal to 6. So now all we're going to do is take those numbers and substitute and solve. All right, let's do it. I'm going to start in the middle here, I think. So x equals, so it's negative b, so that means my b becomes negative, so it's going to be negative 9 plus or minus, I'm going to write this a little bit higher because I feel like I might run out of space. negative 9 plus or minus, I'm going to explain this plus minus here at the end, so just sit tight with that. The square root of 9 squared minus 4ac. So I've got my a is 2 and my c is 6. Everything is going to be divided by 2a, so 2 times 2. Okay, so let's start to simplify this here. So this equals negative 9 plus or minus the square root of, square root of 9 squared is 81. Okay, 2 times 6 minus 2 times 6 times negative 4. Okay, minus 48. And that's going to be divided by 4, which equals negative 9 plus or minus the square root of 33 divided by 4. Okay, so the reason we have plus or minus in the quadratic formula is because our roots have, when you take the square root of a number, it in fact has 2 roots, right? So if we think about the square root of 4, right, it can be 2 or it can be negative 2. So what the quadratic formula has done here is allowed us to kind of do a little, oh, it's not showing up. Okay, I think it's showing up now. I lost my train of thought. Anyways, what we're able to do here at this point is actually split up the positive root and the negative root like so. So I'm going to write this over here. So x equals negative 9 plus the square root of 33 divided by 4. And over here I'm going to have x equals negative 9 minus the square root of 33 divided by 4. So if you go ahead and calculate that, you're going to get over here x equals approximately negative 0.81. Remember, we have to round here. And on this side, I'm going to get x equals approximately 3.69. That little dot above the equal sign means approximately. So then, if this question was asking you, like, what are the x-intercepts of this quadratic equation, you can do this with the quadratic formula, and then you would write, therefore, the approximate zeros are negative 0.81 and 3.96, and then you should probably put in that it was rounded, so you would write to the nearest hundredth. Okay, so even though when we first looked at this, let me get a different color here, equation, right? You would probably start with how you factor any quadratic equation. You would ask yourself, okay, what number, when I multiply it, is going to give me positive 12, but when I add them, it's going to give me positive 9. And you probably would go through your options, right? You would write out your factors. We would need a little section over here. This is where your factors go, right? Your product would be positive 12. So like 1 times 12, well, that equals 13. 2 times 6, that's 12, but that equals 8. Okay, so something's not working. It's appearing that you can't factor it. So before you say it's not factorable, before you say there's no solutions, you would stop this process here and go into the quadratic formula. okay? Let's do another example. Here I have 4x squared minus 12x equals 9, okay? The first thing I have to do is make sure that this is written in the appropriate form, right? ax squared plus bx plus c. Right now, my c value is on the right side of the equal sign. So let's rewrite this, and we'll do it down here. So what it's going to look like is 4x squared minus 12x, those stay the same. Sorry, this should say minus 9. And then it becomes plus 9, and we're going to set it equal to 0, right? Because we want to find the x-intercepts. So this is the process you follow again anytime you're trying to factor, to go from standard to factored form to find your x-intercepts. If I look at this right now, I'm noticing that it's actually a perfect square trinomial, so you could solve this by factoring. But because the quadratic formula is real-life sorcery, we can actually still use it here to find out the roots of this quadratic equation. So let's try it. We have a value for a here, which is 4, a value for b here, which is negative 12, and a value for c, which is 9. Okay, so let's go ahead and substitute those into our quadratic formula, which I'll just rewrite here for you. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. And we'll have our little pink box around it. Lovely. Okay. So I need a color here. What's going on? Oh, it's not writing. Let me see. Okay, I think we're good to go now. Sorry about that. So it's x, perfect, equals, where was I here? Negative b. So this is what you're going to write. You write minus, and your b value is 12, so you have to write it like that, right? Your b value, is negative 12, so you have to write it like that. Plus or minus the square root of negative 12 squared minus 4, and then my a value is 4, and my c value is 9, divided by 2a, so that's 4. Okay, let's simplify. So we've got my negative 12 is just going to become 12 because it's like negative 1 times negative 12. So we've got 12 plus or minus the square root of 144 minus, 4 times 9 times negative 4, minus 144 divided by 8, which equals 12 square root of 0 divided by 8, which really is 12 over 8, right? Because this is a 0, which means my root is equal to 3 over 2, or if you were writing it in decimal form, it'd be equal to 1.5. If you recall from our previous video, when we only have one value for x, that means it's representing the x value in our vertex, and it's also the x value of the axis of symmetry. Okay, so if you're ever doing something in the quadratic formula and you find that you have to, quote unquote, find the square root of 0, you know that you're only going to be given one value for x. So that one value for x gives you the x coordinate of the vertex. It also tells you the axis of symmetry is x equals 1.5, right? The x-coordinate of the vertex is x equals 1.5. Let me put that up for you. Okay, there it is. It's come up. Sorry, my iPad is really fighting me today. All right. While we're talking about the vertex, there's actually a new way to find the x-coordinate of the vertex while working in standard form. So I think what we're used to is when we're working in standard form, we will take something like this, we'll factor it, right? So we'll end up with terms inside of brackets, and then we take those values and we add them and divide by 2 to get the x-coordinate of our vertex, right? So if you already have your quadratic relation in standard form, you can actually find the x-coordinate of your vertex using this equation here. So let me just see where I can write this. I'm going to put a little squiggly line here. So in standard form, another way to find the x-coordinate of the vertex is x equals negative b divided by 2a. So if you want to find the x-coordinate of your vertex and you have your quadratic in standard form, you can substitute that information into this equation here and you will find the x-coordinate of your vertex. Okay, so we're going to do another example here where we're not just using the quadratic formula to find the solutions, which are the zeros. We're actually going to use it to find the vertex as well, the equation of the axis of symmetry, and then we're going to sketch it. Okay, so let's go ahead and set up our quadratic equation off to the side here. Negative b plus or minus b squared minus 4ac divided by 2a. I'm also going to rewrite the relation we've been given, which is 5x squared plus 8x minus 3. Okay, so before anything happens, I need to rewrite my relation because I see that it's not set to equal to 0. And that's what we need to do in order to find our zeros, is we have to set y equal to 0 to find the x-intercepts. So let's go ahead and just rewrite it. 0 equals negative 5x squared plus 8x minus 3. Okay, so what's my a value here is negative 5, my b is 8, and my c is negative 3. So let's begin by substituting and solving. Okay, I've got okay, so let's start first with the x-intercepts here. That's what I'm starting with over here. So x equals, okay, negative 8 plus or minus the square root of 8 squared minus 4 times negative 5, negative 3, 4ac. I got that right? Yes. Divided by 2a. Okay, that equals negative 8 plus or minus the square root of 64 minus 60 divided by negative 10, which equals negative 8 plus or minus the square root of 4 divided by negative 10. Okay, so here I'm going to make some more space first. I'm just going to move this up here. That's better. So I've got my plus over here. So x equals negative 8 plus the square root of 4 divided by negative 10. So that's going to give me, you should write this underneath. I'm just really running out of space here. That's going to give you x equals 1. Okay, and then over here, I have x equals negative 8 minus the square root of 4 over negative 10. So x is going to be equal to 3 over 5, and I'm going to also write that as a decimal, or 0.6. Okay. I'm just going to make some more space here by erasing some of this information here, because we've already substituted in. So now we're going to do the vertex. So to find the x-coordinate of the vertex, this here was x-intercepts, right? Hopefully the color coding helps you. So to find the x-coordinate of the vertex, well, we're going to use that new equation that I just showed you, which was x equals negative b over 2a. So all I'm going to do is take my a, b, and c value. I know I just erased them. I'll rewrite it here. A equals negative 5, b equals 8, c equals negative 3. Maybe we'll just draw a little bubble around them so we don't mix them up anywhere. Okay, so I have I'm going to write this. So I've got negative here. We've got 8 divided by 2 times negative 5. So that equals negative 8 over negative 10, which is equivalent to 4 over 5 or 0.8. So you just found the vertex. That also happens to be the equation of the axis of symmetry, right? Because that's the x-coordinate of the vertex. So therefore we know the vertex is not the vertex, the x-coordinate of the vertex right? And then therefore the axis of symmetry is equal to 0.8 as well. Now what if you wanted to find the y-coordinate of the vertex? It's not in this question here, but if you wanted to find the y-coordinate of the vertex, which means you want to find the y-coordinate here, I'm circling it in green, all you would do is take your x-coordinate of the vertex, substitute it into the original equation, and solve it. So y would be equal to negative 5 times 0.8 squared plus 8 times 0.8 minus 3. And then you can go ahead and solve. I just realized here that the last part of the question asks you to sketch the parabola. I don't really have much space for that here, but if you were to sketch it, oh, I gotta turn this beyond this layer here. There we go. Right? I know where my zeros are, so I know where my x-intercepts are, here and here. I know where my vertex is, so I can just plot the points as I usually would and sketch it. I know it's opening downwards. I see I have a negative a value, so you can go ahead and sketch the parabola based on all these points that you found. Now, we're going to try one more example / scenario. So let's just say a parabola has the equation y equals x minus 2 squared, all squared, plus 3. All right. So first we're going to state the coordinates of the vertex, the equation of the axis of symmetry, and the direction of opening. So they're asking for the vertex. Do you notice something here? Y equals x minus 2 squared plus 3. Does it look like this? What is that? That's vertex form. That's a gift. If they're asking you for the vertex and it's in vertex form, you can look at your h value, you can look at your k value, and you can determine that the vertex is going to be at 2, 3, right? We remember that the sign gets flipped because of the way it gets substituted into vertex form. Okay, so we found the vertex. The equation of the axis of symmetry we know is the x coordinate of our vertex, so the axis of symmetry is x equals 2. And what is the direction that this parabola is opening? Well, what's my a value here? It's positive. So we know that when we draw this parabola, it's going to be opening upwards. Now, what if you were asked to determine the x-intercepts? Okay, let's just do a rough sketch of where this parabola would probably start. Okay? If you remember, our vertex is 2, 3. So let's see, 1, 2, 1, 2, 3. Okay, so I'm going to plot it right here. Here's our vertex. Do you remember the direction the parabola is opening? It's opening upward, like this. I'm going to use a different color. It's opening upward, right? And here is 2, 3. So what are the x-intercepts? This is where the x-intercepts happen. What do you think they're going to be? Does that parabola look like it's going to have any x-intercepts right now? No, it's not going to, right? There will be no x-intercepts because the vertex of the parabola is above the x-axis. X-axis, I think I said axis. And it's also opening upwards. It opens upward, right? If this same parabola opened downward, well then it eventually would have x-intercepts, but that's not the case here. Now, you can verify this by using the quadratic formula to prove it. So that's exactly what we're going to do here. So I have y equals x minus 2 squared plus 3. I know that if I want to go from vertex form to standard form, I'm going to expand and simplify. So this is going to look like this. I have x squared minus 4x plus 4 plus 3, which equals x squared minus 4x plus 7. I'm just simplifying without a step in here. You can do the extra steps. Okay, so now that I have this written in standard form, I can rewrite it, but set it equal to 0, right? Because if I want to find the x-intercepts, I have to let y equal 0. So it's going to look like this. 0 equals x squared minus 4x plus 7, right? And now we can use the quadratic formula and take this information and substitute it in. So I'm going to do that. I think I'm going to do that up here. So I have x equals, oh, let's write our a, b, and c. A equals 1, b equals negative 4, and c equals 7. Okay, so I've got x squared minus b plus or minus the square root of b squared minus 4ac divided by 2a, which equals 4 plus or minus the square root of negative 4 squared is 16 minus 28 divided by 2, which equals 4 plus or minus the square root of negative 12 divided by 2. And now at this point you think we would do what we were doing before, right? But we don't need to, because this has given us a signal here. You remember before when it was 0, that told us something? Well, now this is telling us something again. You cannot take the root of a negative number. So since the square root of a negative number is not a real number, therefore there are no real roots here, right? So we have no solutions. We're going to have no zeros because x does not exist. Our x-intercepts do not exist.